good morning. So what is going on in this graph? You should have opened your notes page that says at the top, interpreting non-linear graphs. Interpreting non-linear graphs. So you should have your notes page open in Cami. You should be ready to pause the video at any time in order to complete the notes as we go through. So the learning target is to interpret the graph using vocabulary such as linear and nonlinear, constant, increasing and decreasing, and describe what is happening. And then we're also going to ask you to sketch a graph. So that is exactly what the standard is asking us to do. After the first video, you should be at least in the in-progress message. You may not know all of it, but you should definitely be in progress. And sketching it, you may not be quite ready yet, and I am totally fine with that. So first of all, what is the biggest difference between these two groups of graphs? Well, in group A, you should be able to notice that they are all straight lines, and that group B, they are all non-linear. So this is the first way that we can describe a line. It is either linear or non-linear. So if you can now understand that straight lines means it is a linear graph, and you couldn't do that before, you are learning. And these are non-linear. They do not have a straight line. But you could say, but Miss Wood, the one at the bottom has two different straight lines. It is made up of two linear lines, but it is still a non-linear function. So we're going to draw some pictures, and that might be a little difficult in your notes. You could use the different shape sections. You can figure it out. I have faith in you. Do your best. So linear means there are going to be straight lines, which means there are three different types. We're not going to do vertical lines because those are not functions. Non-linear means it can be a squirky or curvy or zigzag. Increasing means that as you look at it from left to right, it's going up. Decreasing, as you look at it from left to right, it is going down. Now, where the graph begins, it is not going to be here. It is going to be on the y-axis. And it will show you this. It is here along this axis. Steeper means it is faster, so I want you to draw a line that is steeper than that one. Flatter means it is slower, not fatter. Flatter means it is slower, so it goes down. Maximum should be the highest point. Minimum is the lowest point. And if there is no change, it is going to be a flat line. So what's going on here? There aren't numbers on this graph. Well, we can tell this by first starting with the information that's here, the key features. So by the title, well, we know that Jacob is taking an afternoon stroll. Okay, we know that this is time, so this is where time is 0. This says distance from home. If that says distance from home, that means home is here. And if he is going up, he's going away from home. And if he's going down, he's going towards home. These are not hills. These are not showing him going up and down a hill. This is showing him going from home towards home, but it is not showing direction. This is showing distance. It is not showing direction. Okay, we're going to label each of these sections and then we're going to write some things about it. So if you could label each of these, I would appreciate it. Now, those particular sections, from the previous video, we know that steeper is flatter. Steeper is faster, flatter is slower. Steeper is faster, flatter is slower. So my question to you is, where is he going the fastest? So where is he the steepest? And you should have said A. He is going the fastest in section A. So where is he going the slowest but still moving? In section C, he is going the slowest. Why do I know that? Because it is the flattest. It is not quite zero. It's not no change. So E is going to be a medium pace. We can tell B and D, the distance from home doesn't change, but the time does. So one of the students says, oh, well, they're taking a break. Okay, they're taking a break from moving. They're not going anywhere. They're taking a break. So what's happening in this afternoon? So Jacob starts at home. He's going the fastest, so maybe he runs to his friend's house. Even let's go faster than that. He takes a skateboard to his friend's house. And for quite a bit of time, this friend is hanging out at his friend's house. So what kind of things could he be doing? Oh, they could be playing a video game. They could be listening to music. They could just be hanging out at the friend's house, having a snack. But, so the first one is you're going fast to your friend's house. B section is you're going to be taking a break. Your distance isn't going to change. You're going to be hanging out at your friend's house. C, maybe you and your friend together go for a walk down to the park. And because you're with your friend, you're walking slower. So you left your skateboard at his house. And that's okay. Then you're hanging out at the park. And then E would be you're heading back towards home. And so you don't really want to go home, but it's time to go home. And so you're walking by yourself faster than you would have gone to the park because you're not with your friend anymore, but not as fast because you don't have your skateboard. And you could make up your own little story, but that's my story that goes along with it, and I'm going to stick to it. All right, so what about this one? So we're going to look at our independent and dependent variables. The independent variable is our time in hours. Our dependent variable is the amount of water in gallons. And so someone noticed very quickly that it went down very fast. So it's the number of waters goes down very fast. They drained something. And then we looked at it and said, okay, what did we drain? We drained something that had 15,000 gallons. Well, that means we're draining probably something like a pool. Now, what are some reasons that you would drain a pool? Well, number one, it could be cleaned. Number two, maybe it needs a repair. Maybe it's got a leak. So it sits here. Maybe you guys are doing the cleaning or the repairing on it here. I'm going to say it's a repair. And then what happens here? Here you're going to fill up, but you're only going to fill it up a little bit. You're going to fill it up slowly. Now, why would you fill it up slowly? I think this supports my idea that there's a repair. If you've cleaned it, you can just fill it up at a constant rate. But by filling it slowly, you're trying to make sure that your repair is good and that it's not going to leak anymore. And so you don't want to put all of the water back in, so you have to drain it all back out. You just want to put a little bit of it in to make sure that your repair is good. So you're going to fill it slowly so that you can test your repair. And then, rather than filling it up with a hose at this point, you're just going to get one of those pool trucks. There's these trucks that drive around with pool water in them. And they're going to fill it up real quick. Now, something else to notice is that it started at 15,000 gallons and that it ended at 18,000 gallons. That means it had more water in it after than it did before. Why would there be more water in it after than there would be before? That again is going to support that it needed repaired. Maybe there was a leak. And so it couldn't be filled up all the way. Or maybe it was a situation where they hadn't filled it up for a long time because there was a damage to it. So I think that this is a repair, and that's what happens in this scenario. And sure enough, within the context of this problem, that has what happened. Okay, what about the story of the tortoise and the hare? Well, if you know the story of the tortoise and the hare thinks that he is the fastest animal on the planet, and so he challenges the tortoise to a race. And the tortoise says, sure, why not? So the tortoise takes off, and he goes at a constant rate. And I know it's a constant rate because it's a straight line. The hare's like, oh, I'm going to give him a head start. How do I know that the hare gave him a head start? Well, because he sat there for 2 minutes, taking pictures, doing his hair, whatever he was doing. But for 2 minutes, the hare sat there, still on the starting line. And then he ran super fast, and he ran steeper. He was running very fast. And he passed the tortoise right here. This is when he passes the tortoise. He passes the tortoise and gets way ahead of him, and he's like, I've got this in the bag. He sits down next to a tree and he takes a nap. And unbeknownst to him, as he's napping, the tortoise has caught up with him, passes him, and he finishes before the hare does because he took a nap. I just told a story on a graph. Isn't that crazy? Okay, so let's look at this again. So we have this section where you are stopped. Section E and C are almost the same steepness, so they're going the same speed. And it says distance from home. That means we start at home. So Jillian's trip to school. Well, I know we start at home. What's going to happen? I've had 2 stories given to me today. The first one is, we walked to the bus stop, stayed at the bus stop, got on the bus, went to the next stop, picked up the next group of kids, went on to school. and school is right here. The story that I used to tell, because I would always get stopped by the stinking train, was that I got caught behind a bus, stopped at the bus stop, got around the bus, got stopped by a train, and then got the rest of the way to school. That's how I would get to school. Or, let's say you run to the walk to your friend's house, catch a ride with your friend. So you're waiting around till your friend's ready to go. Then your friend drives to school, but you decide you want to stop at Starbucks on your way to school. That way you have Starbucks when you're at school. There were 3 different stories all about the same graph. And does it all represent it appropriately? Yes. Make sure that it's slower, stop, same speed, stop, same speed. You should be able to describe qualitatively and sketch a graph. Oh wait, I clicked the wrong button. Okay, so on your paper now you should be sketching the graph. So you should be sketching an idea that someone is leaving their house in the morning and running to a bus stop. And then riding the bus to school. Spending the day at school learning a lot. Topher's parents then drive him to soccer practice. And then Topher gets home just in time to have dinner and finish his homework. So, starts at home, runs to the bus stop, rides the bus, stays at school. Parents pick him up and take him to practice, stays at practice, drives home. Should have looked something like that. So when you add numbers, and that's where the final piece, we're actually going to be looking at delta math. So your assignment after this is to be on delta math. And on the delta math assignment, you're going to be doing graph stories. So when you're doing this, please pay attention. During a snowstorm, Caleb tracked the amount of snow on the ground. When the storm began, there were 2 inches of snow on the ground. So if I were to start this, I would put a 2 here on the 2 inches of snow on the ground. The snow fell at a constant rate of 3 inches per hour. So 3 inches means I'm going to go up 3 per hour. That's 1 hour. And it says, and I'm going to keep reading again, until another 6 inches had fallen. Well, that's only 3. 1, 2, 3. That's 6. So I clicked it again once I got here. Now, if I didn't like that line, if it's wrong, I click in the middle of the line. So again, I start at 2 inches. I go up 3, 1, 2, 3, over 1. 1, 2, 3, over 1. Okay. Then the storm stopped for 3 hours. How do I show that it stopped? I do a horizontal line, and that's 1 hour, 2 hour, 3 hours. It then starts again and at a constant rate of 1 inch per hour for the next 2 hours. So starts again, 1 inch per hour. So I go up 1 over 1 for the next up 1 over 1, 2 hours. As soon as the storm stopped again, the sun came out and melted the snow. So now we're melting. That means it's going to go down. And it melted the snow for the next 3 hours at a constant rate of 2 inches per hour. So it's going to go down 2 inches and over 1. Down 2, over 1. And this is for 3 hours, so I do it 3 times. So you are going to read a scenario and graph it very similar to this. Now, if you get it wrong or if you get it right, what's important to show or read is, look, if you don't understand how to do it, please notice it shows you how to do it a different way. So it's saying at 3 inches per hour, 3 inches per hour, cross cancel, it's going to take 2 hours. They're showing a different way how to do it. Okay? And again, some of them it's snow, some of it's going to a store. Some of it's temperature. So on a spring day, the time of the day and the temperature in degrees. So at 6 a.m., so we're not going to start here on the line. We're going to start at 6 a.m. It was 50 degrees. So I'm going to leave a point. It's at 50 degrees. For the next 4 hours, so from 6, 7, 8, 9, 10, the temperature rose at 2 degrees per hour. Well, so if it's 2 degrees per hour and it's 4 hours, that means it would go up 8, right? So it would go 1, 2, 3, 4, 5, 6, 7, 8. And you can see that you go up 2 over 1, 2 degrees per hour. Up 2 over 1, 2 degrees per hour. Up 2 over 1, 2 degrees per hour. For the next 5 hours, it rose 1 degree per hour. So from here, it's going to go up 1 over 1. Up 1 over 1, that's 2 hours, 3 hours, 4 hours, 5 hours. The temperature stayed steady. That means it's not going to go up or down until 6 p.m. So I just made sure that it was at 6 p.m. And then for the next 2 hours, it drops 3 per hour. So 1, 2, 3 down. That's 1 hour. 1, 2, 3 down. That's 2 hours. The temperature dropped then steadily until the temperature was 55 degrees at midnight. So midnight and 55 degrees. See, that's all you've got to do. Okay, please make sure you do your delta math. Show me that you know how to do this, and I will talk to you all soon.